Okay, we're going to collect a lot of information with partial derivatives and then use that to estimate f of 1.8, 4.8. So to do this, we need to go through part A first, in which we want to evaluate the original function at 2, 5. So it's going to be looking at the natural log of 10 minus, we're going to replace the x with 2 and replace the y with 5. Which I believe this works out to be natural log of 10 minus 4 minus 5 is the natural log of 1. Well, the natural log of 1 works out to be 0. So on that spot, in our formula, we're going to go ahead and fill in a 0. F of xy is approximately f of ab. The a is going to be our 2, and the b is going to be the 5 as we get going on these. All right, next what I'm going to do is take the partial derivative of our function f with respect to x, and then we'll evaluate it at 2, 5 as well. So remember, as we do this, we're going to treat x as though it's our only variable. Any y's that show up or any other numbers, we treat them all as constants. So we're going to use the chain rule. Initially, with natural log, we're going to go 1 over the inner function multiplied by the derivative of the inner function with respect to x in our case, because it's a partial derivative. So the derivative of the 10 is going to be 0. The derivative of this middle term, negative x squared, is going to be negative 2x using the power rule. And the derivative of the y, we're treating that as a constant, so derivative of a constant will be 0. Next, we want to evaluate this partial derivative with respect to x at 2, 5. So that's going to be negative 2 times 2. I'm going to put that part in the numerator, over 10 minus 2 squared minus 5. That denominator is going to work out the same as it did up above. So we're going to get negative 4 over 1 is negative 4. So that's going to get filled in right here for our partial derivative evaluated at ab, in our case, 2, 5. Next, that gets multiplied by x minus our value for a we said was 2. And then finally, we want to figure out what's the partial derivative with respect to y and evaluate that at 2, 5 as well. So pretty similar as far as getting going on here. We're going to start out with the chain rule. Derivative of the natural log, the outer function, is 1 over 10 minus x squared minus y, times the derivative of the inner function this time. One term at a time, we have 10. Its derivative 0 because it's a constant. The middle term, we're treating this as though this is all constants. So derivative there is going to be 0 as well. But the derivative of this last term is going to be negative 1. So this times negative 1. Finally, we need to evaluate that at 2, 5. So 1 over 10 minus 2 squared minus 5, all times negative 1. Well, again, that entire denominator works out to be 1, just like it did up at the very first evaluation. So we get negative 1 in the numerator divided by 1 makes negative 1 overall. That's going to get filled into this partial derivative evaluated at 2, 5. And at the end, we have y minus our value for b. Well, we said 5 was our value for b. So this is the formula that will give us an estimation. To finish this up, all we need to do is evaluate this estimation formula at 1.8, 4.8. So I'm going to skip the 0 minus and go straight to negative 4. 1.8 gets filled in for our x, minus 1, and then 4.8 gets filled in for our y. A little bit of algebra and we'll have our estimation. So negative 4. 1.8 minus 2 is negative 0.2. Minus 1. 4.8 minus 5 is again negative 0.2. Negative 4 multiplied by negative 0.2 is going to be positive 0.8. Plus, as negative times a negative makes a positive, so negative 1 times negative 0.2 makes positive 0.2. Add these together, we're going to get 1 for our approximation or estimate. So I hope this helps out. Just take it one step at a time, going through your partial derivatives and filling in the correct values. Good luck.